Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 8, 2026, exactly 1 week ago. It introduces a massive new benchmark built from autobiographical narratives, revealing that while standard retrieval methods help with facts, they fail at deep person understanding, with even advanced models scoring only about 22% on complex insight tasks. The paper is titled, KnowMe-Bench, Benchmarking Person Understanding for Lifelong Digital Companions. And as we'll see later, the discovery of a specific update paradox has really significant implications for the future of AI memory systems. And for those interested in the implementation, the authors have shared their code on GitHub. To understand the motivation, Figure 1 compares current methods with this new approach. On the left, existing benchmarks rely on low-density traces, essentially just dialogue logs that lack internal context. Because they miss real-time inner thoughts, models often fail at complex reasoning. In contrast, the right panel shows how KnowMe-Bench uses autobiographical narratives. This captures situational details and inner monologues, enabling the model to answer deep questions, like identifying how a specific person influenced someone's life choices. Well, Figure 2 details exactly how the authors built this benchmark using a rigorous 4-stage pipeline. It starts at the top left with Stage A, where a segmentation agent breaks raw narratives into chunks. Next, the process moves to Stage B, atomic unit extraction, which converts text into structured data points. Crucially, notice the consistency check agent here. Every generative step uses a verify and revise loop to ensure accuracy. Then, Stage C constructs a precise timeline. And finally, Stage D synthesizes the narrative, with human literary experts providing the ultimate quality check. So, Table 1 breaks down the performance results, and Panel B highlights a critical failure mode called the update paradox. In this flashback dataset, the MEM0 system actually drops 3.5% on temporal tasks because it mistakenly overwrites the current state with past flashbacks. By comparison, Panel C shows that for the event-dense dataset, MEM0 dominates, boosting entity consistency by nearly 12%, since its graph structure handles concrete details well. Finally, Panel D reveals that for psychological insights, even the best methods hit a ceiling, meaning deep understanding remains an open challenge. Alright, Table 2 visualizes these trade-offs using radar charts. On the left, with the QN3 backbone, notice the green line representing MEM0. It spikes at the top right for detail and entity tasks, which confirms it excels at retrieving static facts. In contrast, the red line for memos pulls ahead in the bottom and left sectors, specifically for time, conflict, and insight. This demonstrates that while graph memories win on precision, stream-based architectures are essential for the complex narrative reasoning seen here and in the GPT-5 chart on the right. Okay, to ensure data reliability, Table 3 specifies the thresholds for automatic quality control. It lists the divergence limits that trigger a revision if the generated text strays too far from the source. Notice that for Module C, the realignment phase, the threshold is absolute 0. This imposes a strict logic check because timestamps must align perfectly with the causal graph. In contrast, for modules B and D, the system permits slight variances of up to 5%, which allows for stylistic flow while still banning hallucinations. Wrapping up, 2 takeaways stand out. True person understanding requires more than just retrieving facts, and handling the nonlinear timeline of human memory remains an unsolved challenge. The update paradox specifically proves that current architectures need better chronological reasoning to become genuine lifelong companions. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.